way to remember. So the first rule, a parallel light, the light ray which is coming parallel to the principal axis will get reflected through the focus. That was the first rule. And remember, when I'm saying this rule, it's not like it's something new. It is happening because it is following the law of reflection. Angle of incidence will be equal to angle of incidence will be angle equal to angle of reflection. All right. So what was the second rule then? Can anyone remind me?
That the convergence of curvature.
Yes, we learned like that. So when we took the light coming parallel, it passed through the focus. So then the next thing we can say that let the light go through the focus any direction, either this way or you can make it go this way, anything. So let's say I make it go like this. So now this is your point of incidence, but I will not draw all that again. So remember that the rule is whenever the light is going through the focus, it will get reflected parallel to the principal axis. That was your second rule. Then Nithya, like what was the doubt? Like these rules you said you already saw, right? So what's the problem with that? Like is there something you're not understanding or what?
I'm not understanding.
So then whatever I'm saying, it's the same thing which I said earlier. So still that will not make sense to you. Yeah. So what's there not to understand? Like, are you seeing that this light ray concept you're not getting, how the light is going parallel and all that? What is it? Like explain your question in more detail a little bit, because these are rules. Rules means this. Okay, guys, can you hear me?
Yes, sir.
Yeah, I lost the network connection for a bit. So everyone is able to see my screen also? Is everyone able to see?
Sir.
Not able to see the screen?
Yes, sir. No.
No, sir.
Okay, 1 second. How about now?
Yes, sir.
Okay. Fine. So Nithya, I was asking, like, I'm trying to understand your doubt. Like you're saying you're not understanding. So can you explain a little bit? Because this is a rule. So rule means there is not much to understand. You have to understand that how light behaves in front of this mirror, and this is something which you have to remember. Like if the light is coming parallel, you should know that you have to make it go through the focus after getting reflected. If it is coming through the focus, then you have to make it go parallel to the principal axis. This is something which you have to remember, not understand.
Yes, sir.
Only thing to understand in this is that whatever rule I am telling you, those rules are happening because of the law of reflection. When you draw the normal, it will always follow the angle of incidence is equal to angle of reflection. So all those rules are happening because of the laws of reflection. But when some light goes through the focus, it has been seen that it will go parallel. So this is something which we should remember always. No need to draw that I and R over there. We will know that if it is going through the focus, that means it will go parallel. Something easy to remember, easy to draw. Okay, what was the third rule then? Anyone?
Light ray passing through C passes through C place.
Okay, good. So whenever there is a light ray which is passing through the center of curvature, focus is here, center of curvature is here. I can make the light ray go in any direction. I can make it go like this or like this, or even from up to down, any direction. If it is going through the center of curvature, let's say like this light, what will happen to it? It will come back through the same path. It will get back reflected through the same path. Why is it happening? That also we tried to understand. because this time, this is your point of incidence, D. And if you draw the normal, you will see that it will follow the same path because the light is also coming through the center of curvature. So what is the angle of incidence here? What is the angle made by the incident ray with the normal? 0 degree. Angle of incidence is 0. So reflected ray should also go with 0 degree. Reflected R should be also equal to 0. That is why when the light is coming through the center of curvature, it goes back through the center of curvature because angle of incidence and angle of reflection, both of them have to be equal to 0. That is 0 degrees. All right. What was the last rule, fourth rule?
Light ray passing through pole passes through pole.
Okay. So if there is a light ray which is passing through the pole, it will just follow something like a plane mirror. That was the rule, right? It will be like a plane mirror. There is nothing different about it. You will just draw the normal, and normal will be the principal axis basically. And this is your P, let's say. So if I'm throwing the light at the pole, hold on. What happens now? Where is the normal? This pole becomes the point of incidence now. So from pole, if you draw the normal, of course, it will be exactly on the principal axis because it has to pass through the center of curvature. So this whole thing, this is your angle of incidence. So you will have to throw the reflected ray in such a way that it is equal to the angle of incidence. I is equal to R. So this is how your light gets reflected back from here. Nitya, is that clear?
Yes, sir.
Okay. So for convex mirror also, the rules are slightly, they're similar, but of course the light cannot pass through the focus or center of curvature. Do you want me to explain that? Convex mirror also?
Yes, sir.
Okay. So the rules for convex mirror. What was the first rule, guys? Again, the same thing, right? Parallel. We throw the light parallel. And what about this? Where is the pole? Pole is here. Focus and center of curvature will be on the right hand side this time. Everyone remembers that? Because the sphere will complete on the right side. This is the sphere from which the convex lens was cut out. So the center will be on the right hand side. That's why center of curvature is here and focus will be exactly in the middle of the center of curvature and pole. Now, if you throw the light parallel to the principal axis, what did we say it will happen? In concave, what happened? It actually passed through the focus, but here light of course cannot penetrate through the mirror. So it has to get reflected, but it will get reflected in such a way that it will appear to be coming from the focus. It will be in the direction of the focus. That is your first rule. And here also, same thing is happening. This is your point of incidence, D, let's say. And if you want to draw the normal at this place, you have to take the line from center of curvature to D and extend it further. So this will be your normal. So this angle here, it is the angle of incidence. This is angle of reflection. So here also it follows the law. But by following the law, what happens is if the light is coming parallel, it will get reflected through the focus. Nitya, is that clear?
Yes, sir.
Okay. So what was the second rule, guys? Quickly, someone tell me. Just the converse of this one, right? Here we made the light go parallel and it got reflected in the line of focus. Now we will point the light towards the focus. Think of it like you have a torch and try to point it towards the focus from this side of the mirror. So what will it be like? If you had a scale, you could draw a line like this, right? Now this light is pointed towards the focus. So if that happens, how does it get reflected back? It gets reflected back parallel to the principal axis. Does it make sense, Nitya?
Yes, sir.
Okay. Third rule. Pointed towards the center of curvature, right? So what you can do is you can think of it like taking a torch and pointing towards the center of curvature. So the light will be something like this. It will be pointed towards the center of curvature. And in this case, it will get reflected back through the same path because the normal is also along the same line. So angle of incidence is 0. So angle of reflection will also be 0. I is equal to 0. So R will be 0. Is this clear? And finally, Nitya, confirm.
Yes, sir.
Okay. Then what was the last rule? You point the light at the pole. So at the pole, it behaves exactly like a plane mirror, or the concave mirror also behaves in the exactly same manner. How it happened here at pole, same thing will happen for convex also. The normal, we know that the normal will be through the principal axis only because it will be the line which will pass through the center of curvature. So this over here is your normal. This becomes the angle of incidence. So you will get the reflected ray, which is following the law of reflection. That is, I is equal to R. So these are the 8 rules which we had seen earlier, okay? And we use a few of these rules, at least 2 of them at a time, to get the image of any point for that mirror, okay? So this is which one is it, 20 or 21? Should have been 21. Okay, so what we will do now, we will continue with the ray diagrams which we were working on earlier, okay? So we had completed the 3 ray diagrams. For concave mirror. Now we are going to go to the 4th one. So before we do that, let's quickly go through what we did in the previous class and look at the PDF. Yeah, so this was the first ray diagram. First one, what happened? Where was the object? At infinity. And you know that parallel light, when it comes, it will pass through the focus. So that is what happened here also. It followed the rule, right? Just now we talked about it. So the light from the top of the object as well as from the bottom, everything meets at focus only. That's why the object is very, very small. So image of A is also at the focus. Image of B is also at the focus. That is the reason the object is very, very small, highly diminished, point size. Okay. So position is at the focus and it is highly diminished. And why is it real and inverted? It's real because the light which started from the object after reflection, it actually meets at the focus. The light reflected ray actually meets at the focus. That's why the image is real. You can put a screen over here at the focus and you will be able to see the image of this object over here at some screen. You can take a white sheet of paper or a cloth, anything, you will be able to see the image. Okay. And the image will be inverted. If you take a candle which is kept very, very far away and you try to project the image of a candle over here, the candle will be inverted. Okay, this object could have been a candle, right? So if you take the candle, you will see the image to be very, very small image will be there, of course, but it will be inverted at the focus. Then second one we saw, from infinity, the object had come a little closer. We had seen all that details, how it comes closer to C. And when that happens, the image shifts slowly from focus to this point, A dash, B dash. And to get this, what did we do? We took one point, the top of the object, and we followed two of the rules. First rule was we made the light go parallel. Reflected ray came through the focus. We followed the first rule here. And then we followed one more rule, third rule. We made the light go through the center of curvature and it got reflected back through the same path. And you see the reflected rays met at this place, A dash. They started from A, but after getting reflected, they met again once more at this place, A dash. And when that happens, wherever the reflected ray meet, that is the place the image is formed. That's the rule. Okay. Wherever the reflected rays meet again after reflection, that's the place where the image is formed. So from B, reflected rays will pass through the principal axis B dash only. So you will just draw a vertical line there and your A dash, B dash will be your image. And you will see that the position will be between center of curvature and the focus, between C and F. So that's all. I think I will not go into complete detail of all this. You can see yesterday's class recording, but I think the audio was not all that great in yesterday's recording. So just try to see if you can follow. And if you have any doubts in these three ray diagrams, you can ask me in the next class, okay? The third condition was we had come up to this point where the object was at center of curvature. And image also came to the center of curvature. See, as the object is coming closer, from infinity, when the object was at infinity, image was at focus. You came a little bit closer, image moved a little bit away from the focus, that is between C and F. You came further close, you came more closer to C. You actually standing at C now, image has shifted to C. So as you are going closer to the mirror, image is moving away. So this thing you can remember, this pattern. As you go close to the mirror, the image moves further away from the mirror. Now, what will be the next case, guys? Tell me. Fourth one, what should I write? Where is the object now?
Between C and F.
Between C and F.
Between focus and center of curvature.
Yes, the object is between center of curvature and focus because we are moving the object closer to the mirror. No, so we have already considered this C. Now we have to go closer to focus between C and F. Okay, so object is between center of curvature and focus. So let's draw. You can all draw along with me. So this is our pole. Center of curvature will be somewhere here. Focus will be exactly in the middle of center of curvature and pole. And MN is the, what is MN? Who can tell me? What do we call this?
Aperture.
Yes, very good. MN is the aperture of the mirror. And what is that aperture? It's basically the diameter of the circle. This mirror we are drawing in 2D, but in reality, when you see it in 3D, it will be like a plate. And when you see from this side, the front view of this thing, it will be a full circle like this. And the diameter of that circle, that is your MN. That is the aperture. Okay. So let's get back to 2D now. 3D you can imagine. So yeah, now where is my object? Between C and F. So I have taken green one, so let's do the same. I can put it anywhere, here, 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 anywhere, okay? So I'm just keeping it somewhere. That object doesn't have to be exactly in the middle of this. It could be anywhere. Now, this is my AB. What should I do, guys? How to get the image from here? Now you know the pattern. What will I do? I'll take the top of the object, the point A. From there, I will consider 2 light rays and see where they meet. To find a point, I need 2 lines, right? At least wherever the point of intersection is. So first one, I'm going to take, as usual, the parallel. I will throw the light parallel. It's not like I am throwing the light. Light is going in all sort of direction. We are considering this particular ray, which is coming parallel to the principal axis. Because we know that this one coming parallel will go reflected through the focus. Okay. Now, what other rule can we consider?
Sir, passing through poles.
Yes. See, we can do anything. Like I said, we can make it go through pole, but that's the one something which you should try to avoid. Making the light go through the pole, because it's difficult to draw the exact angle. This angle, whatever you have to draw exact same angle down here, no? So it will become slightly difficult for you to draw the exact same angle here and here. So unless there is no other way, try to avoid that 4th rule, that is going through the pole. So you can make the light go through the focus and it will get reflected parallel. We can do that, right?
Sir,
Yes.
so what will happen if we choose a ray that will go through center of curvature?
Yes, it will. If the light ray which is going through the center of curvature, that means it is in the line of center of curvature. Let's do that. So we'll have, for that, we'll have to make this thing a little bit bigger, or maybe make my object a little smaller. Hold on, let me fix this.
Sir, here, why are we doing that?
You will understand. See, if I keep my object very big, if you want to make the light pass through the center of curvature, it will go above something over here, no? So you'll have to extend your mirror beyond this point. So that's why I'm making the object a little smaller, so that I don't have to make it very big. You see, if I keep object very small, what will happen to this? The light, which is, it will go like this. This is the line of center of curvature, no? This is how it will go towards the mirror. And since it is going in the line of center of curvature, it will get reflected back through the same path and it will come out through the center of curvature this way. Can you understand what's happening here, all of you? The light started from here, from A, it went in the direction of the center of curvature, in the line of center of curvature, I mean. So because it is in the line of center of curvature, it got reflected back and it came through the same path like this way. Tell me if that makes sense. Light went in the line of center of curvature and got reflected back through the same path.
Yes, sir.
Okay, see, I understand that there is a difference in this, because whenever your object was away from this side, whenever your object was this side, let's say, then you are able to directly throw your light in the line of center of curvature, no? It was going towards the mirror. But since your object has crossed this side, now if you throw the light and make it go this way, it will go away, no? Will it get reflected back ever? If I point my light towards the center of curvature, Will it get reflected through the mirror? No, right? So you always need to point the incident ray towards the mirror. That's why I'm throwing, even though I'm saying that I want to point my light towards the center of curvature, but I am actually throwing my light towards the mirror. Pragati, is that what you're confused about?
Yes, sir.
So is that clear now? Why we are doing that? Why are we pointing it towards the mirror? Because we are studying the reflection of the mirror, right? So we have to always point the incident light towards the mirror. But if you want to do it along the line of center of curvature, then what do? You take your point A over here and you take your point C, take a scale and join that. And this line, what you get over here, you can throw the light along that line towards the mirror, not away from the mirror. Okay?
Yes, sir.
Okay. So let me clean it up a little bit. Yeah. So anyone has any questions? That's okay, obviously. Yeah, so we have pointed the light towards the center of curvature. So this was, let's say this is our first rule. We made use of this rule. And then other one, of course, we'll make the light go parallel because that is easy to draw. And the parallel ray gets reflected through the center of curvature. And you see that it will go and meet somewhere over here. So this is where the light is meeting again after getting reflected by the mirror. So this is where the image of A will be formed. A is here, the image will be called as A dash. Correct? So this is your A, B, and the image is A dash, and B dash will of course be exactly, you can draw the line straight like this. No need to worry too much about B dash, okay? It will be along the principal axis only. So just put your rays towards the light which goes from the B towards the pole, it'll get reflected back through the same path like this. And the image of B dash will be formed over here. Okay, let's talk about the nature of the image now. Tell me guys, what's happening here?
Position is beyond C, sir.
Yes, we study position, and position we are seeing that it has crossed the C, beyond C. And size and nature. These are the three things we need to understand: position, size, and nature. So what is it?
Size is large, sir.
Size is, yes, larger than
Bigger
the
than
object.
the object.
Enlarged. We in science we call it as enlarged image. Okay. Enlarged means it is bigger than object. Okay. So and what about the nature, guys? Tell me quickly.
Real.
Real and inverted.
Yeah, real.
and inverted.
Yes, absolutely. As you can see, A dash is down and B has gone up. So this is inverted image. And since the reflected ray actually meets at this point, so this is why this is a real image. Okay. So this is real and inverted image. Okay. Let's quickly take up the fifth rule also, which is along the same line. So it'll be easy to draw. Where should be my object this time? I'm moving closer to the mirror, remember. I was at C, then I came between this. What should be my next position?
Focus.
Focus, sir.
Yes. So my object should be exactly at the focus. Okay, so let's draw it quickly. This is my pole, center of curvature, focus, and the aperture MN. This time my object has to be exactly at the focus. So I'm going to draw a small object like this so that we can easily. Okay, now what should I do? Where should I throw my light? Tell me, ideas, anyone?
So first one will be parallel.
Okay, let's take the parallel light. Parallel light, what will happen to it?
Pass through the focus.
Focus.
Okay, very good. Parallel light will go through the focus. Then
Curvature, sir.
From curvature.
yes, we can make it go through the center of curvature. But see, since I am drawing with free hand, if I rely on my drawing, of course, it will not be perfect, right? So we need to do a little bit of cheating over here. So I know that when the object is at the focus, the image is formed at the infinity. It's very, very far away. So the light which is reflected, it should come actually parallel to this reflected ray. Okay, whatever this reflected ray we had taken, the other ray should also be parallel to it. So I will just do a little bit of cheating and shift my C in such a way that the light will actually be parallel. So actually this is where my C should have been. But it's hard to do it by hand drawing. So this is something you will also do in your exams. You will have to do a little bit of smart work. You make the light parallel and then put your C point C over there.
Sir?
Yes, tell me, Pragati.
So, but in actual, we have to like put focus in the center only, no?
Yes, yes.
Like in actual ray diagram.
Yes, see,
Where
actually,
we won't be using this smart work.
no, see, when you are actually drawing with the scale, see, I am drawing with free hand. That's why my drawing may not be perfect. But if you take a scale and draw the mirror perfectly like that, if you take 3 points which are equal distance apart, C, F, and P, let's say if this part is 5 centimeter and this is also exactly 5 centimeter, then when you draw the lines, no, it will actually be parallel for you. These lines will be parallel for you. You will not have to do cheating. But since I am doing with free hand, you understand that my distance from here to here is not exactly same. That is why I was not getting parallel lines. So I had to do a little bit of improvisation and I had to make the lines parallel and then put my point C over there.
Sir?
Yes, tell me.
So won't it have to meet, like intersect each other to make?
Yes. See, when the light is parallel, we say that this line will meet, but it will meet at infinity, means very, very far away. Okay. So you might think that it will be little bit bent and.
Oh, but parallel lines never meet.
Yes, that is true. They never meet. But whenever lines don't meet, that is what you call that. Yes, tell me.
Virtual image, sir.
No, this is not virtual image. This is not virtual image. We still call it as real. Because this may appear to be parallel, but it will not be exactly parallel. The difference will be so small that it will meet very, very far away. It will go and meet actually. Okay.
So, sir. So what will be the size of the image?
The size is very, very large, highly enlarged. We don't even know where the image is. So it will be very, very, we can't even draw the image. We say that the image is highly enlarged. Let's write about the image: position, size, and nature. So what did I say? Where is the position?
At infinity.
Yes, it is meeting at infinity. And remember this infinity, don't confuse again with maths infinity. This infinity for a mirror could be a few meters apart, 30, 40 meters, maybe 60 meters apart, anything. There's no fixed rule for that, how many meters apart the infinity starts. Okay, depends on the focal length of the mirror. You will understand more thing when we see the mirror formula and all, okay? So infinity. Size, highly
Very large.
enlarged. That's what we call as highly enlarged in terms of physics, okay? Nature, still real and still inverted. As you can see, image of A dash will be down somewhere over here, B dash will be somewhere along the principal axis, so it is real and inverted. Okay. Fine. So we have seen 5 rules, 5 ray diagrams related to concave mirror. And we started with infinity and we have come close up to focus. So
one is left.
So one more is remaining. Where do you think the object will be in the last one?
Between focus and pole.
Yes, between focus and pole. And when that happens, you see, I was telling you that when we go close to the object is going closer to the mirror, image is going further away. So after going further away, it has gone to infinity already. Where else it will go after that? There is no other way to go. So what happens in the last case? Image has become virtual now. It can't go beyond that. Think like that. Can't go beyond infinity. So the image becomes virtual and actually image gets formed behind the mirror this time. So we will see that image, that ray diagram in the next class, okay, tomorrow. So practice these 5 ray diagrams and you have to practice it many times, so many times. Only then you will be able to draw this. Don't take it so lightly. This may seem very easy to draw, but when you actually start drawing, you will get confused. Okay, it's not, line is not meeting, the line is not getting parallel. So those things you will come across only if you practice your ray diagrams many times, okay? Fine, so any questions from today's class, guys? Tell me. No?
Sir?
Yes, Pragati, tell me.
Sir, this at infinity can be even light years?
See, normally it's not that far away, okay? Because if the image has gotten that far away, we will not be able to see, but it can be. There is no rule that it cannot be, okay? Depends on where the object is, what is the size of the object and where it will really meet. Depends on the configuration of the mirror, but don't think in terms of light years away, okay? Infinity means just a few meters apart also. It is still real and the light is actually meeting somewhere far away. Okay.
Thank you, sir.
Okay then. That's all for today, guys. Yes, tell me, Ritesh. Tell me.
I have doubt.
Yes, go ahead. Tell me.
Sir,
Yeah, go ahead. Tell me.
sir, they have given right chemical name for silver bromide, sir.
Chemical name for?
Silver bromide.
Not able to hear you. You do one thing. You type it in the chat window. There's some backgrounds.
Okay, sir.
Not able to hear you clearly.